maybe it isn't really good user interface. But anyway, user interface layout, there's sort of this concept that's been in user interface systems. Many are very similar. You can sort of use the same basic concepts in Java or in GTK or in Windows. So if you have that's what I get for full screen mode. If you have a dialog like this, if I resize it, both the width and the height are acting as input, and it's very different from this traditional one. And the Firefox user interface actually pretty much works the same way as you resize the window. The stuff around the edges stays the same, roughly the same size, and all the space in the middle is allocated to the web page. But that was sort of a digression, but one that I find sort of interesting. So back to the main area of the talk. So examples of document format standards on the web are things like HTML and Zool and SVG. And one thing that a lot of these standards have in common is that they're based on a tree structure. So this is an example HTML file. And it has a bunch of tags in it. So there's an HTML start tag, and an HTML end tag, and a p start tag, and a p end tag. But what all of this is it's a linear representation of a tree structure. So the tree structure for this document looks like this, where the HTML element is the root element. Or maybe you sometimes think of the tree as having a document that's the root, and then a root element that's inside of that, depending on how you think about it. And I simplified this here by ignoring the text. But what a bunch of these document format standards are based on is this tree structure. Now, the serializations that they use are actually a little bit different. So the things that are, there are sort of two things that are interesting about this tree structure. The first of them is how you get from the linear representation of it that's sent over the network to the tree representation of it that you store in memory. And then the second is what you can do with this tree representation of the data structure in memory, what's stored in it, how you can change it, and so on. It's worth noting that Mozilla stores this tree structure in memory. Not all browsers do that. Having the tree in memory tends to make implementing many other web standards easier, because a lot of the standards are described in terms of this tree structure. But some browsers have chosen to optimize their layout engine so that they don't store the tree structure in memory.
So which are those?
So we don't know everyone else's source code, but what I've heard about Internet Explorer is that they don't, which leads to it makes some things interesting, because the DOM APIs have methods for traversing the tree, and sometimes with Internet Explorer you can do interesting things with those APIs, where you can go into an infinite loop following next sibling links. because it tries to reconstruct the tree from some other data structure.
So you are saying that it's not that they don't store in memory, but they actually don't have that.
Right. They store a different structure.
Right.
So some browsers will store a linear structure in memory rather than a tree structure. Netscape 4 also did this. It parsed HTML into a linear display list structure, and then it's sometimes hard to figure out tree relationships from a linear data structure. So having an actual tree data structure in memory made implementation of things like CSS and the DOM a lot easier. And that was really one of the big changes when Netscape decided to throw away the old Netscape 4 layout engine and switch to Gecko. Probably the most important architectural change there was having a document tree structure in memory as a tree. So I want to talk a little bit about parsing. I'm going to avoid going into too much detail on any one thing, because if I do, I'll talk way too long. So there's really two different parsing code paths used for these document formats. The first is the one that's used for most HTML on the web. Anything sent with the MIME type text/HTML. And the parsing rules for text/HTML have historically not been defined, because early web browsers parsed this thing that was supposed to be a tree structure into a list structure, and supported a lot of weird things like start tag for B to make it bold, start tag for I to make it italic, end tag for B to stop it being bold, and then an end tag for I to stop it being italic. And that's not a tree structure, because one of them isn't inside the other. One starts here and ends here, and the other starts here and ends here. So the ways that web browsers that started using a tree structure have come up with to correct that kind of thing vary between browsers and are not well documented. And once you start doing things like applying CSS to them or using the DOM on them, you get results that vary between browsers. So there's actually some... Well, let me pause for a second and talk about the other parsing thing and then come back to that. So the second parsing path is the XML parsing path, where Zool or SVG and other XML-based document formats use. So basically, inside this directory in the source tree, and I'm trying to give rough descriptions of where in Mozilla the code is that does these things. There's two directories inside the parsing code that deal with XML. One is this XPath library, which is an XML parser written by James Clark that we and many other projects use. And then the other half is the code that connects that to the APIs used in the rest of Mozilla. So what these parsing implementation, what all of these parsers are required to do is, as they read in the tree structure, they send a series of notifications that describe the tree structure to whoever is using the parser. And the thing that's using the parser would be an implementation of either the NSI content sync interface or the NSI SAX content handler interface. And those are actually responsible for building the actual tree structure.